Hey, I'm Giuliana Galeazzi, and today I'm going to be presenting my project for physics for this bimester. I'm going to be talking about two subjects, momentum and centripetal force. Okay, first let's talk about momentum. Momentum is a fundamental concept in physics that measures the motion of an object. It is all about how difficult it is to stop something that's moving. Momentum depends on two things, the mass of the object and the mass of the velocity. So how fast it's going or how slow it's going. Mathematically, it's expressed as P equals m times b, where P is momentum, m is mass, and b is the velocity. Key points about momentum. First of all, direction matters. Momentum is a vector quantity, meaning it has both magnitude and direction. If you're dealing with two objects in opposite directions, for example, two cars going like one up this way and the other one like this, their momentum can cancel out when combined, and that's when they crash because of the different momentum and of the different speed. 2. Conservation of momentum. In a closed system where no external forces are acting, the total momentum before an event, like collision, is equal to the total momentum after. This principle is super useful in analyzing things like car crashes, explosions, or even how planets move. 3. Different scales. Momentum applies to everything, from tiny particles to massive objects. In quantum mechanics, particles like electrons have momentum, while in classic mechanics, we talk about cars, rockets, or sports balls. Okay, now I'll talk about 3 examples of momentum in different scenarios. Okay, first we have car collisions. For this, imagine 2 cars on the road. A small car moving at high speed, like really fast, has a lot of momentum, while a larger truck moving slowly can have a similar momentum thanks to its greater mass. If they collide, the conservation of momentum principles helps determine how they will move afterward, and well, this is why heavier vehicles tend to cause more damage on accidents, because they have more momentum. They carry more momentum. Then 2, kicking a ball. Okay, when you kick a soccer ball, your foot applies a force to the ball over a short time that is called impulse, changing its momentum. If the ball is stationary, like it's just there, standing there, like this, I'm not applying any force, like just there. Well, all it's new in its momentum comes from your kick. Like, it's just there, and the force that you put on it is like all the momentum it has, because it was just steel. Centripetal force. Centripetal force is the force that acts on an object moving in a circular path, directed toward the center of the circle, or the axis of rotation. It's not a new kind of force itself, but rather the name given to the resultant force that causes the object to move in a circular trajectory instead of flying off in a straight line. Well, why does it happen? Like the cause. Well, when an object moves in a circle, its direction is constantly changing, even if its speed remains constant. According to Newton's first law of inertia, an object in motion tends to continue in a straight line unless acted upon by an external force. In circular motion, the object is continuously pulled toward the center, preventing it from moving off in a straight line, like just whoop. Formula for the centripetal force Fc, it's the next one. Fc, that is centripetal force, it's equal m times b squared divided by r, where m is the mass of the object, b is the speed of the object, and r is the radius of the circular path. Now I'll give some examples of this. First, we have a car turning, like you can see, like there, the BMW. Well, when a car turns around a curve, the friction between the tires and the road provides the centripetal force that keeps the car on the curved path. 2. Satellite in orbit. A satellite orbiting Earth experiences centripetal force due to gravity, which pulls it toward the Earth and keeps it in its orbit. And 3. Spinning a ball on a string. Like I don't know how it's called in English, but I think it's like lanzamiento de bala or something like that. Well, when you swing a ball tied to a string in a circle, the tension in the string provides the centripetal force, like you can see right there in the picture. Like when you have a string and you have like the ball like that, you can feel like all the time like a force acting up like on you, like you're gonna fall if you like something is happening, that you just feel like you're just gonna like go in a straight line if you like leave the ball. So that's why you keep turning and turning and turning. And yeah, well, to finish this project, I'm gonna give a little conclusion of both momentum and centripetal force. Well, momentum and centripetal force, as we saw, demonstrate the intricate relationship between motion and force, things that are very important in physics. Momentum reflects how motion is conserved and transferred, as seen in collisions and interactions. Centripetal force, on the other hand, showcase how forces redirect motion, enabling objects to follow curved paths. These concepts together emphasize the balance and interplay of physical principles, providing a deeper understanding of both linear and circular dynamics. They are not just theoretical ideas, but essential tools for analyzing and explaining real-world phenomena, from planetary orbits to everyday motions. So basically, like understanding these things, momentum and centripetal force, helps us to understand basically like our everyday, like, yeah. And well, I hope you liked my video. I really liked the subjects that we saw this bimester, and I hope I continue liking them. They were easy to understand, and nothing. Thank you for everything, and yeah, good evening or good night. Bye.